Alright guys, I think this should make our final video of our final lesson, of our final unit of this year. So as we finish up continuity, we just want to work through a couple more examples here, but we've pretty much hit the heart of the content already in the first video or two. But as we work through some examples, I just wanted to make sure that we have a fully rounded understanding of the content. So let's look at the last example on this page. Basically, it's similar to the last couple we did, but this time it says multiple choice for an AP exam would look something like this. Given a table of values with a missing value, we know a little bit about it. We know that this graph is continuous from -2 in the x to 3. Some of the values, so 7 and 5. It says if we know that h of 4 or h of x equals 4 is not a solution, let me interpret this for us. So if we have a graph, let's see, we go like this, and this. Like that. So we know we have these two coordinates, -2, 7, -2 way up here at 7. We have 3, 5, so we're over here. We know that the graph has to cross through between 5 and 7 in the y-axis. We have to, we're continuous from -2 to 3, and we go from 7 to 5. So we know that any values between 7 and 5, because we are continuous, any values between 5 and 7 work. Now, it's not guaranteed, but there's a possibility that all sorts of other numbers could work, right? We can get to point B from point A in lots of different ways. We don't know the equation. We just know that it's guaranteed that any values between 5 and 7 work. We also know, I'm going to make this one this very different color, so 4. There goes my straight line skills. All right. We also know that h of x equals 4, so y equals 4, this kind of mostly straight line at y equals 4, there's no solution here. What that means is our graph cannot cross that line. If we are continuous, I can't cross 4, but I can come down close to it. I can go up as high as I want. I just can't go below 4, because if I did, I would be crossing -4, and we know that y equals 4 is not a solution on this interval. So if I can't cross 4, but I have to go from -2 to 3 without lifting my pencil. See, I can't like do that and then lift my pencil and then come back, open circle. Like I can't do that. I'm continuous, so that's not an option either. So what values, it's asking, what values can I be on the interval? Well, -1. -1's way down here. Can I get to -1 without crossing the 4? No. So that's not an option. -1 doesn't work. This 4, I believe, actually that should be -4, but no matter what, whether it's -4, because that's even worse than -1, I still have to cross it. But even if it's +4, it's still the same answer, because it's telling me right here, h of x equals 4 has no solution. Therefore, a cannot be 4. So no matter what, whether that was a positive or -4, it doesn't work. Now, 6 on the other hand, 6 fits nice and neatly between 5 and 7. So yeah, absolutely, at some point, I am guaranteed to cross 6. So A could be 6, we don't know, but it's at least a chance. It says what values are possible. So the only one option is 3, so the answer is C. All right, there we go. Now, we are not going to focus too much on this, but I will touch on this very briefly. it's talking about the composites of functions. So if I have a function f of x, and we know it's continuous, and we have a function g of x, and we know it is continuous, then if we were to combine these, just real quick, I will try and give an example of this. So if I have f of x equals 2x, and g of x, there we go, equals, well, what the heck, 3x squared. Those, by the way, are two continuous functions. We're not ever going to be to a point where we have to lift our pencil to make this thing work. So if we were to say f plus g of x, so this first one, the sum of these two, this is a new function, but that new function is taking f of x plus the g of x. And what it says is, as long as f was continuous and g was continuous, then the composite sum f plus g, so 2x plus 3x squared, itself is also continuous. We can change that and say f of x minus g of x, 2x minus 3x squared. Same thing's going to happen. We are going to be continuous on this graph. You can try this. Graph f of x in Desmos. Go down to line 2, type in 3x squared. In line 3, put 2x minus 3x squared. You will see that it is continuous. 2x minus 3x squared, 2x plus 3x squared. Heck, you could even do 2x times 3x squared. Well, what is that? Well, that's 2x times 3x squared is 6x cubed. Okay, well, that's a graph that looks something like that. I mean, it's stretched a little bit in one direction, but it's still continuous. So anyways, all of these graphs are continuous. That's all it's saying. And, oh, I could have sworn there were more examples. Okay. Well, we're on to practice problems, so I guess I'll end the video here. If you have any questions, please reach out. You can email me. You can come see me in Power Hour, whatever it is. But this is our last lesson, last unit. Our unit test is coming up here in a few days, so please let me know if you have any questions. Otherwise, I hope you've enjoyed the videos.